113 math student, and as I'm finishing up my course in G113, I thought I'd look back and reflect at what the course has taught me and how I've grown from it. After learning about statistics in our course, I wanted to learn more about machine learning and data science because of the relevance that we have today. So what I found to be a really good resource is Kaggle.com. They can access a bunch of data sets, they can compete in competitions, they can learn to code, and all of the IDEs, the Python environments are all set up, so you don't even have to download everything. It's really nice to work with because it's user-friendly and it's very easy to get into. They have everything that you might need to start learning data science. So the nice thing about Kaggle is that it already has a lot of data sets built in. So what I found the hardest when I was looking for data science projects was looking for appropriate data models and data sets that I could work with. So a lot of data sets, like let's say if you take a look at data sets in the Philippines, there's really not a lot of information or data that's easy to work with. But with Kaggle, let's say we want to take a look at the effect of COVID-19 on educational stress. And this is actually like a good data set that I found interesting and I tried working on. So now the first thing we want to do is we've got to import some things that we'd like to use. So Cborn is what's going to help us visualize this data. So if we go ahead and run this, we don't get any errors. And of course the next thing we're going to do is to import the data that we need. So So now that we have our data ready, we're ready to take a look at some visualization so we can make sense of this data. We can jump into that right away. So something we learned from the course is that we're actually doing descriptive statistics. So what we'd like to first do maybe is to take a look at the bigger picture. Let's take a look at our data set and see what the bigger picture is. Let's start to plot things. If we go sms.barplot, exploring Kaggle, I came across another data set that's called academic performance. And this data set, it makes use of linear regression, and it allows one to kind of predict the grades that a student would have given certain attributes. So I thought it would be interesting to take a look at this. Given all these attributes, we'd like to be able to predict the final grade of the student. So basically what we're doing here is we take our huge data set and we're just going to get the attributes that we'd like to see. So we want to see how study time, failures, absences, as well as the grades in G1 and G2, we want to see how these affect the G3. So this is now what our table looks like. It's a lot smaller because we took out everything that we wouldn't need. And in this little piece of code here, we're saying that we would like to predict G3. So we are creating an array here in the first line that drops. So we're going to disregard the column G3, and actually we could replace this with predict. And this will be the feature, meaning what we're trying to predict. And we're going to create an array that will store the results. We need to split our data into testing and training data. We will use 90% of our data to train, and the other 10% is to test. The reason we do this is that so we do not test our model on data that has already been seen. I'm going to create a model with linear regression. Next, we will train and score our model using the arrays that we created in the previous lines. By doing this, we can see how accurate our model is using these attributes that we've chosen. So how we do this is linear.fit, so we're creating the line of best fit using the xtrain and ytrain values. Given the x-test and y-test values, we're asking the algorithm to give us a score so that we can see the accuracy of our model. This gives us an accuracy of 90%, which is actually really good for our first try. That means our training values and our test values are actually very compatible, and we've picked very good attributes to predict the final score that we want. So seeing this accuracy score is pretty cool. It tells us how much the line of best fit works in our example, but I thought it would be better to take this a step further so we can actually predict like real life examples. Finally, with the use of our model, we can use the attributes that we had before. So we're going to use the period 1 score, the period 2 score, the hours, the study time hours, the failures and absences. Then we're going to use these to predict the G3 for particular students. So we found that we have an accuracy of around 90% here with this test data. And we'll take a look at actual predictions that our model has actually made. So if we take a look at this, the coefficient here, these are actually the slope values. So these are the m values of the lines that we have used. So because we have 5 variables here which is our G1, G2, study hours, absences, and failures. These are the slopes for each line. And whereas we also have the y-intercepts. So we're actually looking at a 5-dimensional array because we picked 5 attributes to base our model on. So, well, the values that we have here, this is our predicted value. The first number is our predicted value. These are the actual results that we're basing on, and this is the real G3 store that we can compare our prediction to. So what this line is telling us is that the student had a score of 11 in G1, a score of 12 in G2, and his study time was 1 hour. He had 0 failures and 0 absences, which led to the student's score of 10, which our model actually predicted to be 11.8, which is quite close actually. So if we take a look at another line, let's say this one's really close. Our model predicted a 10.15 score, given a score of 12 in G1, a score of 10 in G2, a study time of 2 hours. We have 1 failure and 18 absences. So the actual score was actually 10, but our model had predicted a 10.16, which is really good. So we can see that with the use of linear regression, we're able to make these predictions given some attributes, and this just allows us to compare our results to what the actual values are.
Using math as a tool, statistical research gives managers the information they need to make informed decisions in uncertain circumstances. When managers analyze statistical research in business, they determine how to proceed in areas including auditing, financial analysis, and marketing research. Statistical research in business enables managers to analyze past performance, predict future business practices, and lead organizations effectively. Descriptive analytics look at what has happened and helps us explain why. By using historical data, managers can analyze past successes and failures. Those who use statistical research in business should be familiar with how statistics are calculated, including how the mean, median, and mode work together to create meaning from a set of numbers. Successful managers understand that these concepts worked in concert to create an accurate picture of a business's condition.